Now the test for convergence of the series is called the root test. So for a given series, we would like to test it for the convergence. So let's say our series is given something in the power of n, right? So let's say this is going to be our general term of the an is something in the power of n. So in this case, we can use the square, so the limit of an in the module in the power of 1 over n. So when n goes to infinity, or the limit of, so which is the same as absolute value of the an from the root in the power of n. So if this limit exists, right, and this is equal to the L, so if this limit exists and this is equal to the some number L, where this L is less than 1, then the series an is absolute convergent. Absolute convergent. So the second case where this limit exists and this is equal to some number, some finite number, but it is more than 1, or if this limit does not exist, doesn't exist, then in this case the series is divergent. And there's a third case where this limit, the limit of an in a module in the power of 1 over n, 1 over n means like a root in the power of n goes to the infinity, is equal to the 1. In this case, the test is inconclusive. Okay, so let us check this for the following series. So we're given an example. So our series is given in the form Tn plus 3 divided to the 3n plus t in the power of n. n goes from 1 to the infinity. So we can write down a couple of first terms of the series. If I substitute n to be equal to the 1, it's going to be 1 in the power of 1, right? So t plus 3 divided to the 3 plus t. If I substitute the t, it's going to be 4 plus 3, which is 7, divided to the 6 plus t, which is 8, in the power of 2. Plus, if I substitute the 3, it's going to be 6 plus 3, which is 9, divided to the 9 plus 2, which is 11, in the power of 3, and so on. So in order to test the convergence of the series, we're going to use the root test. So let me first of all write down the nth term of the series. It is going to be Tn plus 3 divided to the 3n plus t in the power of n. So the module of this nth term in the power of 1 divided to the n is going to be simply Tn plus 3 divided to the 3n plus t. So when we need to find the limit of the Tn plus 3 divided to the 3n plus t and goes to the infinity, we would just like multiply the both numerator to 1 over n and denominator to 1 over n in order to find the limit. So we can find the limit by multiplying 1 over n to all the terms here on the numerator. It's going to be t plus 3 over n divided to the 3 plus t over n. So when n goes to the infinity, this term and this term are going to go to the 0. So that is why what is left is simply t over 3. So the limit, this limit exists, and this is equal to some number which is less than 1. So that is why the series Tn plus 3 divided to the 3n plus t in the power of n, when n goes from 1 to the infinity, is convergent. And it is not only convergent, it is absolutely convergent.